PowerShell scripting, working with object hierarchies. Now the idea here is to work with hierarchical information. So a hierarchy is something like a folder having subfolders. And a lot of management objects we work with kind of work the same way. A computer has multiple disks. The disks have multiple volumes, stuff like that. So I'm going to show you how to work with object hierarchies, how to display it, how to dig into the hierarchy. I'm also going to show you how to create tools that produce hierarchical object-based output. So this will be a short nugget, and I'm going to start by showing you how to work with object hierarchies, including selecting and expanding deeply into a hierarchical object structure, how to use the format custom commandlet to automatically expand all that, and some of the gotchas people tend to run into when they run into objects that have a hierarchical structure. And I'm going to show you how to create your own. We're going to create an object that starts with computer information and then includes a collection for as many disks as that computer has. So we'll create that kind of multi-level object-based output. So kind of the basic, I guess, outline of what we want to do is create output that has a hierarchy to it. So for example, let's say we're going to query some information from a computer. So we've got a computer, and we might collect information similar to other functions we've already written in this series. The OS version, maybe the BIOS serial number. And let's say we also want to include disk information. Now, the trick is that a computer can have multiple disks. So what we want to do is create a property, perhaps called disks, and that in itself consists of multiple disk objects. Each disk object might have size, free space, and there can be more than one. So I need to show you, first of all, how to create a function that produces this type of hierarchical output, and I want to show you how to work with that type of hierarchical output because, quite frankly, Windows PowerShell has lots of places that already do that type of hierarchical output. For example, let's pop open PowerShell here. If you run get service, GSV, you'll notice, let's just grab, any of them. We'll pipe them to format list star. You'll notice that required services, for example, this curly bracket notation indicates that this contains multiple other service objects. So we can start by learning how to work with that. For example, get service, select object, and rather than selecting a property or a list of properties, I'm going to expand. Now you can only expand one property at a time, so I'm going to expand required services. And what I get out of that is a list of other services that are required. So typically this is only going to make sense if you get just one service. So let's do get service. We'll specify a name, WinMGMT. Okay, so the service Win Management has a required services property. I've expanded it, and it consists of one other object, and that's the RPC service. So let's also let's take a look at RPCSS. RPCSS. That's required services property, consists of two. It also has DCOM launch and RPC endpoint mapper. So this idea of creating hierarchies of object and then being able to work with those is kind of interesting. Now, there's a little trick that a lot of folks, maybe this is more of a gotcha than a trick. Looks something like this. Get service, export CSV services.csv. CSVs are a flat file format, meaning it can only contain really one layer of a hierarchy's data. What happens when you try to put a hierarchy in there, at least in PowerShell, is you wind up with stuff like this. So here's that property again. The second column of our CSV is required services. And here's what that data ends up looking like. PowerShell is saying, hey, this column contains one or more service controllers, an array of service controllers. That's what the square brackets means, an array. But every single one is the same thing. A CSV file doesn't provide a way to break that hierarchy down, to actually show you what's in there, because it can't put multiple entries into this one field. And that's why CSV is really such a poor way of persisting a lot of the data that's in Windows PowerShell. A better approach is to use XML. Because XML, when you get down into those hierarchy type portions, actually has the capability of breaking it down a little bit if you want to. So you can see that it's able to do that. Now, there's also another neat thing. Check this out. Get service, format custom. Format custom knows how to break things down as well. So we get a service controller, and we can select particular properties. So let's add let's go name, status, and required services. And you'll see that as I select out a required service, so here's a service controller, this is WWAN SVC, I selected its required services, and that gets broken down. So Format Custom understands the concept of a hierarchy, and it displays things in this form to represent that hierarchy. And you can even, there's some parameters of that. Let's take a look at the help for FC. And you can tell it how far to expand out. That's what the depth is. So it can take a hierarchy and really expand it out through multiple levels. So working with these things is one thing, but I want to show you how to create them because that's kind of an important trick too. Let's pop open the ISE. And I'm going to go grab my Get OS, or my OS Tools. Oops, that's the manifest, not the module. I'm going to grab my OS Tools module. And I've already got this Get System Details and Get Disk Details functions. I'm going to kind of expand and combine the two of them. So we're going to create a new function. Function Get System Sys Details. Oh, what should I call this? Sys Disk Details. I don't know. That's not a great name, but we're going to stick with it. Commandlet binding, because I always do that, so it becomes an advanced function. Parameter block. Here, we'll just copy this out of here. Boop. And in fact, I'm going to copy the whole process block out of here. We're going to use this as a complete starting point for the entire thing. So I'm already retrieving the operating system, the computer system, the BIOS information. All that's great. In here, though, I want to also get the disks. Disks equals get WMyObject class Win32 logical disk from computer name minus computer. Now that's going to return more than one thing. So I'm going to create a disk collection and just set it empty, equal to an empty array. Now for each disk in disks, so this is where I'm going to enumerate and go through each disk one at a time. I'm going to create a new disk object. Disk props first. We'll do the little hash table here. So let's put in the drive letter. And that is the disk.deviceID property. Keep everything nice and lined up. We can put in the drive type. Disk.drive type. And let's put in the size. Obviously, you can put in whatever other information you want to. Just trying to keep this pretty basic. Disk object equals new object, type name PS object with those properties. Now we need to add that to the disk collection. Now, I do have to tell you something here. Whenever you create an array like this, and you're going to add things to it, you kind of have to be thinking a little bit of performance in the back of your head. You see, the .NET framework doesn't really like the idea of arrays that can change sizes. So when I run line 16, it creates an array of 0 items. When I run line 22, it has to create a new array of 1 item, copy everything that was in the old one, which is nothing, and then add this new thing. The next time I come through, it creates a third array with 2 items, copies what was in the old array, and adds the new item. And then it gets rid of the old one. The point is that every single time you add an object to an array, you're creating a little bit of overhead. The bigger the array gets, the more problem that overhead is going to be. Now, most computers are going to have less than a half dozen drives, so that's not a problem. This is just not a technique that's going to scale well to hundreds and thousands of objects in an array. But the idea is that I'm creating a custom object for each of my disks. I'm adding those objects to a variable, which will be a collection of them. And then once I've fully populated that collection, I'm going to add the collection as a property of my top level object. So we're kind of building the hierarchy, I guess you could say, in reverse. So I'm building the disk object, oops, and then I'm building the next disk object, and then I'm building the next disk object, and then I'm building the top level computer object, giving it a disk's property and attaching those to that. So you kind of have to work your way backwards through the hierarchy in order to really pull this off. So let's save this and remind myself what the heck I called it. Get sys disk details. That's a terrible name. Get disk sys details. Computer name, localhost. Let's see if that works. Oh heck, either I didn't save that or I've got an error in here somewhere. Let's see. I'm just going to check my code here real quick. Most of that looks okay, and I don't see any squiggly reds. Let's just try loading the module. Import module OS tools. Get disk sys. See, still not pulling that in. You know, this is going to be a good time for a little about troubleshooting, I guess. I'm going to take this whole thing out. This is one way to troubleshoot things in a module too. It's probably good to show you this. I'm going to put this in a variable or a script all by itself, and then here I'll put get disk sys. Just not parsing it at all. Get disk sys disk details. Boy, terrible name. There we go. Computer name, localhost. I'm going to save this, localhost. Test.ps1. Yeah. And let's just run this to see if I get an error message right away. No, I didn't. Okay. So you can see here that it has produced the disks. It's telling me that each disk has a drive letter, a drive type, and a size. There's 1, there's 2, that's my C drive, and there's 3, that's my D drive. If I wanted to work with those directly, I could pipe it to select, expand, disks. We'll run that. And see, then I get the actual objects outputted for those with the drive type and the size and everything else. I'm not entirely, seems to be running fine. I'm not entirely sure why it's not running super smoothly here, but I have had this ISE open for a while, and I've had the shell open. Might just need to close everything down and maybe reboot the computer and try again. Let's just give this one more shot. Get sys disk details. Yeah, see, it still doesn't want to do it from there. Import module OS tools. Yeah, sure. Get command module OS tools. Get sys disk details. Now it's working. Yeah, sometimes you do just have to shut everything down. And that's my custom view that's kicking in, because I will bet you I forgot to take the custom type name out. Run ISE, and that'll mess me up. Because I did that little copy and paste, remember, to get all my code. I probably copied and pasted one line of code that I didn't really want to. And it's probably, yeah, that right there. Let's just call this sys disk details. Save, remove module OS tools. Oops. Import module OS tools. And there, now it runs. So anyway, the idea is to produce that hierarchy. Now if we pipe that to format custom, you can see that when it gets to that disks property, it's going ahead and breaking it down. And now it's showing me the drive letter, the drive type, and the size for each of those. So how you create this hierarchy of objects and how you work with it is kind of important. You will find this a lot in PowerShell. Now, the neat thing here is look what happens if I just run that command and pipe it to export CSV. And I'm going to run it again and pipe it to export CLI XML. Now let's look at those. See, when I get to disks, it's just an array of objects. It's not really useful information. Now, sometimes the XML won't automatically expand that either. Yeah, it didn't. It knows it's an array of objects, but it didn't automatically expand it. And that's because I'm just creating it with this generic object type. So it doesn't really know to do anything different with it. But the XML could, as you learned in a previous nugget, the XML could store that as a hierarchy by breaking it down into individual pieces. So definitely a useful thing to know. If you're going to create an object, I would rather see you create this type of hierarchy. Then here's what some folks will do instead, and this is the bad thing. They'll create a property, say OS, oh, that's a terrible color, hang on. They'll create a property, say OS ver, and maybe SP ver, and then they'll have a property called disk1, and another one called disk2, and maybe there'll be disk1 size. That's bad, because unless you planned for the computer to have only a specific number of disks, you can never predict how many properties there are supposed to be. Should I have one disk property or two, or do I need three? Whereas what I just had you do was create a disks collection that can then break down into a hierarchy of however many disk objects you need. And I showed you how to work with those. So that's why that's a good approach. And it's definitely something that it remains consistent with the rest of the way Windows PowerShell works. So now you've got an idea of how to work with hierarchical object output. You know how to use select object and its expand property parameter to expand the hierarchy, how to use format custom to view it, and you've seen a few of the gotchas that get involved when you're exporting information that contains hierarchies. Sometimes commands like export CSV and export CLI XML just can't break into the hierarchy. They can't dig into it and create the hierarchy, which means you actually lose some fidelity. You lose some data when you export to those formats. I also showed you how to create a simple tool that creates hierarchical object output. You kind of have to do it from the bottom up. Start with the lowest, most deeply nested objects, and then work your way backwards up the hierarchy. I hope this has been informative for you, and I'd like to thank you for viewing.